Set up that video. I have to decide which class you're in. You all right there? Sweet. Okay, so we're subtracting rationals today. It's based off of what we did yesterday. Here's the deal with subtraction. Our whole goal with subtraction is to change it into what? Into addition. So that's what we're going to do today. So to add or subtract, in this case, we're just going to follow these easy steps. Let's reminders from what we did yesterday. What is our integer rule for addition? Ready, set, here we go.
Same sign, add, different signs subtract to keep the sign of the bigger one so you can be exact. What?
Nice. The what left something to be desired. We say what?
What?
There it is. That's what I'm talking about. Now, good job. That's the idea. That's the rules for addition. Just do the rep. Now, if you like the flow chart, we'll do the flow chart today, just so you can get used to both of them. Now, the subtraction is what we're going to do today. What two skills do we have for subtraction? Keep, change the sign. And the circle method. With a little bit of negative ninja thrown in there in case we need it, right? Negative ninja is a special case of keep, change that lets us get to skip the rewriting of it part. Now, when we keep, change, we have to rewrite that step. When we circle method, we don't. So on the notes today, we're going to do both of them. Let's review what we did yesterday with our flow chart. We're going to be flipping back and forth between the flow chart today, so make sure that you've updated your flow chart with what we did yesterday. So, based on today's notes, what do you think the answer to this first question on our flow chart is going to be every time today? Yes. The answer is going to be yes. Now remember on the yes, we added the circle method in our box. Make sure you've added the circle method to your flow chart. Keep, change, or circle method. And then if it's not a subtraction problem, we'll go no. Okay. Then the next question is, are the signs the same? If the signs are the same, you're going to add. And we underlined add. We underlined that. To make sure that we know that even when we're subtracting, sometimes we add because the signs are the same. Okay. And the last one, last part, step 3, where we have the bigger number going on top, and we're going to subtract. When we get to step 3, it's a subtraction problem. All right, so here we go. Flow charts on the left, the examples are on the right. Let's go ahead and get our examples. We're going to have 3 examples for decimals, 3 examples for fractions. And then we have we'll have one last example where we'll be looking at a number line. So we've got example 1. As you write down example 1, I want you to decide what its sign is going to be. What's its sign going to be? Keegan?
The subtraction sign?
No, the sign is going to be either a positive or a negative sign.
Positive.
It's going to be negative. Let's see why. We'll do keep, change first instead of circle method. I'm going to do keep, change on this one, circle method on the next one. So keep, change. Change the signs. Which one's bigger? Well, it's a subtraction problem, so I did keep, change. Now, are the signs the same? Nope. So I'm going to put the bigger number on top and subtract. Question is, why is it negative? Because the bigger number, 5.6, is negative. So now we're going to subtract them. 5.6 minus 2.4. We don't even have to borrow on that one. 5.6 minus 2.4 is 2.3. And I'm done, right? No, I'm not. What do I have to do? To add my negative sign. Keeping in mind, the sign's going to be negative because the bigger number is negative. 5 is bigger than 2, and 5 is negative. As you copy down example 2, figure out the sign.
Can number 1 also work if you put 2.4 above 5.6? Can I get the same answer by doing that and turning to a negative?
I don't think so. When you subtract, you're always going to subtract big minus small, regardless of the sign. So what's negative 5 minus 5? That's 0. What's negative 5 minus 10?
5.
It's negative 15. It's negative 15. The idea is that we need to make sure we put the bigger number on top whenever we subtract. All right, guys, what's the sign of our answer going to be for this one?
Negative.
It's going to be negative. I'm going to use the circle method on this one. because I want to. I'm going to do a keep, change, change, and a circle method. So this is a subtraction problem, yes. So we did circle method. Are the signs the same? Are the signs the same? Yes, they are. So we're going to add these. So doesn't matter the order, so I'm going to put 3.91 on the top. Remember, we can change the order, can't we? 2.1 with a placeholder 0. I'm adding these. Why? Because same sign, add. Right? So the answer to our problem is going to be negative, but they're the same sign, so we're going to add them. Okay. This is why I like the circle method. It doesn't take rewriting anything. 1, 10, carry the 1, 6. That is my answer. No. Guide me in my sign. Need that sign. Bless you. See, keep, change, change, and the circle method are both good methods. Keep, change, change, you have to rewrite this step. You have to. Circle method, you don't. You just circle them, and now it's just a list of 2 numbers. One more decimal. Oh, sucky now, here we go. My choreographer in high school said, "Oh, sucky, sucky." I loved it. He said, "Oh, sucky, sucky." I never understood where it came from. Does Brad, you know where that comes from?
No, but I'll say it also.
You do? I don't know. Oops. I don't know where it came from. But it was always fun when he said that. We always knew that he was happy when he said that. Is this a subtraction problem? Yes, it is. Yeah, subtraction right there, see? But, who comes out to play?
Keep, change, change.
Name Ninja is a special case of keep, change, change. Hi, hi! What does this say now? Why should we be saying, that's kind of helpful? What do you notice?
They're both the same number.
Same number, different signs. These have a special name. Like a question.
I don't have a question.
Ow. What's up?
Well,
No, go ahead. Share your idea.
good already.
Are you sure?
Yeah.
Okay. If you remember it, just speak up. So what do you see? These are same number, different signs. What do we know about them? They're not integers. Great try though. Different signs of track, yep. They are rational numbers. These are actually called additive inverses. Additive inverse is one of the very first vocab words that we did. Additive inverses are 2 numbers that when added together will equal 0. If you just think about this one, if I take 8.8 steps backwards, then I take 8.8 steps forwards, where am I going to end up? Same spot. I'm going to end up at 0. These are called additive inverses. It's kind of nice that we can see them. They'll equal 0. You'll probably have a few questions like this. Careful though, it does not say this. Do you see that? This is different. Why? What do you notice? They're both negatives. They have the same sign, so we're going to add them. So this is not the same thing as that. Okay? Not the same. Okay? So just keep that in mind. Let's do some decimal, or let's just do some fractions. As you write down the fractions, we'll do 3 fractions now. As you write down the fractions, decide what the sign's going to be as you write it down, please. I know my sign sometimes looks like psi. Luckily, you guys know better. So is this going to be a, or is this going to be a, it's going to be a, why?
Oh, actually, not that bad.
Well, because my psi is going to be negative, right? So a negative psi would be like, positive psi is like,
At least it's not like a bad problem. I thought we were going to fire anything. I just don't like it.
now we're doing example 4. All right, let's take a look. I'm going to keep change on this one. Is this a subtraction problem? Yes, it is. Yes, so let's keep change. Keep change. I get negative 4 1/7 plus negative 5/7. Are the signs the same?
Yeah.
Yeah, they're both negative, so we're going to add them. Luckily for us, this is a pretty easy addition. Don't forget, if you want to structure it this way, some of you guys might be able to do this addition in your head. 4 1/7 plus 5/7. That's cool. If you can't do it in your head, I'll show you a technique to do it. It should look very familiar to you, right? Where's my placeholder 0 going to go? In the whole number spot, right? It's 0 and 5/7. Now I ran out of room to keep working down, so I'm going to just work this to the side. I add those two together. 1/7 plus 5/7 is 4 plus 0 is
6/7.
4. So that's my answer, right? Wrong! Got that negative. Guys, why did I have you identify if it was positive or negative at the beginning? Because we need to make sure that, what's it say at the end of the flow chart? Look at it. What's it say at the end of your flow chart? Don't forget your signs. All right, example 5. Hey, it's equal 0, right?
No.
Wrong.
Keep change.
Bop, bop. What's it say now? 1/3 plus 1/3. Does it say 1/3 minus 1/3? No. So 1/3 plus 1/3 is 2/3. It's a pretty easy question to do, right? I say pretty easy because once we change the signs to make it look nicer, now this becomes a straightforward problem. Okay. How many people looked at that and were like, "Oh, sweet, these will be a 0." Don't raise your hand. Just know, be aware. It could be. You just need to look for it. Okay. All right, last one. As you copy the problem down, identify what the sign is. Sorry, this is the last just specific example. We're going to do one more after this of a different type. I forgot my water over there. All right, you decide on the sign. What's the sign going to be? Negative, good, because 5 1/2 is bigger. I'm going to use the circle method on this one because I like it better. All right, so subtraction, yes it was subtraction. We'll do the circle method. Are the signs the same? No, so we're going to subtract. Bigger number goes on top. Now some of you guys might be able to do this subtraction in your head. Okay? What's 5 minus 4? What's 5 1/2 minus 4? Okay. I was just good. I was just getting a sense of the room. So maybe you can't do this one in your head. So let's write it out. Eventually you'll be able to do this one in your head. Where's my placeholder 0 going to go? In the fraction. My fraction, it's got to be 4 and 0 halves, right? 4 and 0 halves. One half minus 0 halves is 5 minus 4 is, and we're done. Negative 1/2. So how could we have done this one in our head? Well, let's think about it for a second. Just think. What's 5 minus 4? 1. What's 5 1/2 minus 4? See that? Well, just no, I was just thinking the subtraction, not the actual answer. Just thinking of the subtraction. So if we have 5 minus 4 is 1, so 5 1/2 would be 1 1/2. Alrighty, how about this? What's 5 minus 4?
1.
What's 5 and a cat minus 4? 1 and a cat. Okay, listen. What's 5 minus 4?
1.
Okay. What's 5 and a cat minus 4? 1 and a cat. It's the same problem, right? 5 minus 4, 5 and a cat minus 4. The only difference is we have to add a cat in there. 5 minus 4 is 1. 5 and a cat minus 4 is 1 and a cat. It's just, there's a little bit extra. Amen.
I did it a different way.
Did you get one, negative 1.5? Then you're fine. Okay. Questions on this one? All right, draw a line. Draw a line across your paper. Draw a number line. It doesn't have to be a perfect number line. It has to have 3 things on the number line. That's it, 3 things. 0, negative 1.3, negative 2. That's it. That's all that needs to be on your number line. 0, negative 1.3, negative 2. Doesn't have to have all those other tick marks. I don't care. Just has to have 0, negative 1.3, negative 2. Try to make them approximately this distance. Okay. Then I want you to write these instructions. Find the distance between negative 1.3 and negative 2 on a number line. Write those instructions down. Find the distance. So we'll only do 3 things on the number line. It's got to be those 3. That's it. And then write down the instructions, please. Find the distance between negative 1/3 and 2. We have to decipher this problem before we can do it. We have to ask, what is this problem even actually asking us to do mathematically? So we're talking about subtracting things. So today's notes are called subtracting rationals. So what do you think we're going to probably have to do on this problem? We're probably going to have to subtract, but let's talk about why. Let's talk about why. How about this? On my way to work, I pass by this big semi-truck every single morning that's always parked on the side of the road. It's about 1 mile from my house. Work is 2.5 miles from my house. How far apart is the semi-truck from work?
1.5 miles.
1.5 miles. How did you get that? Well, because you could take the 2.5 miles that work is from my house and subtract the 1 mile that the semi is from my house. 2.5 minus 1 is 1.5. So when we're asked to find the distance between these 2 points on a number line, what is this problem actually asking us to do? What's it asking us to do?
Like basically what you would do first is like you draw an arrow from 0 to where like your start is, and then you draw from how far like the semi-truck would be for work, and you draw an arrow from there to where the
Like this? Now what?
You see how many times it took from 1/3 to get to.
Oh no, the red. Cool, I love this picture, but that picture doesn't tell me what to do. I want to know what to do. What is this problem actually asking me to do? Find the distance between those 2 numbers. What mathematically am I going to have to do?
Subtract the 2 numbers.
I'm going to subtract them. It's literally what it is. The distance means the difference. What's difference mean? The answer to a subtraction problem, right? However, there's one big catch. There's one big catch with distance. Okay? When I subtract these, what's the answer going to be? It's going to be negative. Why is that not possible? Ready? How about this? I'm going to start at 0. Here's 0. I'm going to walk negative 2 steps. How far did I travel?
2 steps.
No, I traveled negative 2 steps, right?
No.
Why?
Because you can't go negative, you should go back.
But I went to negative 2.
No, you didn't.
Yes, I did.
You didn't.
I did. I started at 0 and went to negative 2.
You didn't. And this is why you're negative.
In distance, you can't go negative. Negative distance is a direction. Can my distance be negative?
No.
No. That's the big catch. Anytime you see a distance question, your answer is always positive. Which means it's the absolute value. Guys, remember that? The way to make things positive all the time is absolute value. So, Keegan wasn't wrong. He said, well, to find the distance, I need to subtract them, right? So let's subtract them. -2 minus -1/3, right? When I do this, I got my negative ninja coming out. Boom, boom. This is an addition problem now, right? Same sign add, different sign subtract. We keep the sign of the bigger, what? So why, but it's going to be negative, right?
Yeah.
No, it's not, because what we are going to do is we are going to do this. Why? Because we know distance must be positive, and we know how do we make things positive no matter what? We make them an absolute value. I traveled -2, right? Absolute value. Didn't I travel absolute value of -2? Yes, I did. So that's what distance is. Distance is the absolute value. Now let's do this problem and finish it up. Okay, so 2 minus -1/3 is the same thing as -2 plus 1/3. Same sign, add. Different signs, subtract. So let's subtract. The bigger one's going to go on top. So 2 minus 1/3. I have a couple of placeholder zeros I need to put in, don't I? 0/3 and 0, right? Now, many of you guys might be able to just think about this one and know what the answer is going to be. 2 minus 1/3 would be 1/3 less than 2. So 1 and 2/3. Several of you probably can do that when you're ahead, but for those of you who can't, we're setting it up. Now to do the subtraction, I subtract the fractions first. 0 minus 1 doesn't work out well. I'm going to have to borrow, won't I? This becomes 1. I'm not going to borrow 10, I'm going to borrow 3/3. So this becomes 3/3. 3/3 minus 1/3 is 2/3. 1 minus 0 is, and it's negative, right? It technically is negative, but it's the absolute value, isn't it? So my answer is 1 and 2/3. So what's the distance? Distance must be positive. So if I see the word distance, I don't technically need to do absolute value. Because remember when we were figuring out signs? It's positive because it's distance. Distance is always going to be subtraction, but the answer is going to be positive. One more last thinking question. I'll read this out loud. You don't have to copy this one down. This is a thinking question. Temperature, there's a telescope that's measuring temperature on Earth's orbit. The number line shows that the temperature on the hot side is 185 degrees, very hot. But the temperature on the cold side is -388. Find the what? Distance between the points. How do I find the distance between those points? What do I do? What do? I find the of their what? Distance is the difference, okay? But it's always positive. So how would I set this problem up? What is distance? Distance is the, how do we find the difference between two numbers? So what should I do? Subtract what? What do I subtract on this problem? Can you estimate that? 200, 400, -400. What's the distance going to be? Approximately what? What's the distance between 200 and -400? How can the distance be 200 if the distance from 200 to 0 is 200? How about the distance from 200 to -400? I send one of you 200 steps that way, I send one of you 400 steps that way. How many steps are there? Difference is subtraction. You need to actually do it. 185 minus negative 388. Why negative 388? Because that's what the number is. It's still subtraction. Name Ninja, what do we do now? Add them together, it's about 600. Ladies and gentlemen, you need to think about numbers on a number line as a distance. It's about 400 to 200. 400 in the negative, 200 in the positive gives us about 600 total. About 600 total.